Okay, welcome to Overview Part 4. This will be the end of the overview. Since either weekly or at some period of time, we're going to be testing the students to see if they've mastered the facts for a particular family. We will give them a time test to see where they are. Now, what's going to happen most likely is that some students will master a family and some other students occasionally will need more practice. If we were to go on to a second week where we remain on the same family, then there are activities that you can do with the students who seem to have achieved mastery while other students are still learning. I would say that the students that still need practice would be back playing Matchter games still. They would also be playing the Faxter game, and then maybe also playing the Take 5 or Take 10 game where they're removing the pictures and the facts and putting them back together. Meanwhile, for students that, especially during the second week, the students that have begun to master the family of facts, they can be playing the Battleship game, and they can also be doing these Loopster puzzles. These Loopster puzzles will eventually be fun for pretty much all the students. However, in the beginning, they would not be fun if you had not mastered the facts because they're going to take that level of understanding and take it to a higher order thinking level. So this is for students that definitely know the family of facts that we're talking about. Okay, so what I'm going to do is this. A basic Loopster puzzle looks like this. Okay, the easiest level is 3 sets of 3 circles. There's 9 circles, has the name down the bottom, and it says addition only. But a person needs to understand the logic first. So what I'm going to do before I solve this Loopster puzzle, I'm going to go to a blank puzzle. And basically, Loopsters were invented to be similar to Sudoku puzzles. Sudoku puzzles are, in the newspaper and they're wonderful. The problem is that even though they use numbers, they're not really math. They don't actually do any addition or subtraction. They're just logic puzzles. So I'm going to do one or two to make sure we're clear on how the logic works. Let's call this one a 1, 2, 3 puzzle. That means that every row has a 1, 2, 3. 1, 2, a 3 in here, a 1, 2, 3 in here. But then also in every column, you need a 1, a 2, a 3 in every column. 1, 2, 3, 1, 2, 3. So here's how it works. In the newspaper, they would set it up like this. They'd give you 2 of the numbers, and they would say, now, using logic, fill in all the other spaces. So we look. Can this circle right here be a 1? No, because if you look up and down, there's already a 1 in this column. Looking across, can this circle in the corner be a 2? No, there's already a 2 in this row. So we're going to make that a 3. If this guy's 3 and this guy's 1, this one has to be 2. If this is 3 and this is 2, by process of elimination, this one has to be 1. Now look at my center, looking up and down. Can this center one be a 2? No, there's already a 2 there. Can it be a 1? No, there's already a 1 in this row, so it's got to be a 3. If this one's 2 and this one's 3, this has got to be 1. If this is 2 and this is 1, this has got to be 3. And if this is 3 and this is 1, this guy has got to be 2. And that's how Sudoku puzzles work. They're based on logic. Now, what I'm going to do is show you just one more example of that to show that it doesn't matter at all what the numbers are. So I'm going to grab a pen again, and I'm going to do a, let's call it a 3, 7, 9 Sudoku puzzle. And what I'm going to tell you is this one is 3 and this one is 7. So when you look in this corner, can it be a 3? Looking up and down, no, it can't be a 3. Looking sideways, can it be a 7? No. So the only thing this can be is a 9. If this is 9 and this is 3, this has got to be the 7. If this is 9 and this is 7, this can only be a 3. Now look in the middle, looking sideways. Can it be a 3? No. Can it be a 7? No. So this one's got to be a 9. 3, 9, this one has to be 7. 3, 7, this one has to be 9. 9, 7, this one has to be 3. And that's how Sudoku puzzles work. They're based on logic. Again, they use numbers, but there's really not any math. Now, if you jump back to a Loopster puzzle, you have the same 9 circles, except pairs of them are banded by what I call a loop. So this loop means that these 2 circles add up to be 5. These two add up to be 7. These two add up to be 4. These two add up to 5. And this guy can be done by logic. So let's see. It's a loopster puzzle. We're going to be using the numbers 1s, 3s, and 4. I need a 1, 3, 4 in every row, a 1, 3, 4 in every column. Way it works is, let's look at 5. What numbers can add up to 5? Out of 1, 3, and 4, it's got to be the 1 and the 4. Now, I don't know if it goes 1 on top, 4 on bottom, or 4 on top and 1 on bottom. So I'm just going to put, I call these baby numbers. Here's 1 and 4. I don't know which way they go yet, but I know these are 1 and 4. In the first column, I've used up my 1 and 4. So by process of elimination, I know this one has to be the 3. That's the big idea for kids to get, is that if you already use the 1 and the 4 up here, this one has to be 3. Come over here to 7. What adds up to be 7? Well, it's 4 plus 3, but I know I can't put a 3 in the bottom because there's a 3 already. So I'm going to put my 4 right here. And then 4 plus what is 7? 4 plus 3. Coming across in my bottom row, I need to use up a 1, a 3, and a 4. I've already used up a 3 and a 4, so I don't have to know anything. That's got to be 1. 1 plus what equals 5? It's got to be my 4. So now I've used up of my 1, 3, 4. I used up my 1 and my 4. This guy's got to be 3. 3 plus what equals 4? Well, that's got to be 3 plus 1. Now, go back to my beginning. Remember I didn't know which way 1 and 4 went? Well, now I know that I already have a 1 in the top row, so I'm going to make this my 4 and this my 1. And this is the only solution that works all the way around. I have a 1, 3, 4 in every row, a 1, 3, 4 in every column, and all of my addition facts are correct. There are a whole set of these puzzles, 1, 3, 4, 1, 5, 6, 1, 2, 9. Lots of examples that students can practice. These are great for enrichment. Your top students or the ones who've mastered their fact families will learn to see these as fun. And the idea is, if a student doesn't know their facts well, this would not be a fun activity. This should not be used with students that haven't mastered their basic addition facts. What I'm going to do now is move on to here. The next chapter is called 4x4 loopsters. Again, it's the same idea. You have, instead of having 3x3 9 circles, now we have 4 rows of 4 circles. So that means I need a 1, a 2, a 3, a 5 in every row, a 1, a 2, a 3, a 5 in every column. So let's look up here. What two numbers are going to add up to 8? Let's see. Out of my numbers, it's got to be the 3 and the 5. But I don't know which order they go in, so I'm just going to put my baby 3 here and my baby 5 there. Now I come down to here to 7. Now, which ones add up to 7? Well, it can only be the 2 and the 5. But I've already used my 5 in the first column, so this can only be the 2, and this one will be the 5. And here's what's cool. I've already used my 2, my 3, my 5 in my first column, so by process of elimination, I know this one's got to be the 1. 1 plus this equals 4, so this one's got to be 3. Moving along, these two add up to 5. What two numbers down here add up to 5? It's got to be 2 and 3, but I can't put a 3 in the bottom because I already have a 3 in the bottom, so I'm going to put my 2 there and my 3 here. By process of elimination, I've used up my 1, my 2, and my 3 in my bottom row, so the only thing this could possibly be is a 5. 5 plus what is 6? This is 1. Come up to my 4. What adds up to 4? It's got to be 3 and 1, but I've already used the 1 in this last column, so this has got to be my 3, and that's my 1. In my last column, I've now used up my 1, 3, and 5, so that leaves what number? Oh, this one's got to be 2. 2 plus what equals 7? Oh, that's got to be 5. What adds up to 3? Well, that's easy. That's 1 and 2. But I've already used the 2 in the top row, so this is going to be my 1, and this is going to be my 2. Finally, I get back to the beginning, and I now know that I can't, of my 3 and 5, I can't use my 5 up here because there's already a 5 in the top row. So that's got to be 3, and that's got to be 5. Now, I'm assuming by now you're realizing why this would not be fun for students who didn't master their facts. Yet it is actually that much fun for students who did. This will be a great activity to use on the weeks where some students are still practicing a family and other students are ready to be challenged. These will be very challenging. I don't want to make anyone upset, But there's even harder ones. There's 5x5 loopsters. These probably won't even be touched until after Christmas, I would the holiday break, but they work like this. Once our students really know their facts, this is a 5x5 loopster puzzle. It's all the same rules, except now there's 25 circles to fill in. And the way it works is same thing. What two numbers add up to 13? Well, you look down here. I need a 1, 2, 4, 6, 7 in every row and every column. The only two that add up to 13 are, here's my 6 and my 7. Now, which two add up to 9? Well, I look in here, and the only two that add up to 9 are my little 2 and my little 7. But here's what's cool. Looking up now, remember up here I didn't know whether this was 6 or 7? Well, now that I know that I'm using a 2 and a 7 in the first column, this one can't be 7. This has got to be the 6. And now I know that 6, I've used up my 6 and 2 and 7. So the only numbers I haven't used are the 1 and the 4. And look at that. 1 and 4 add up to 5. So now I come along to my 8. What two numbers add up to be 8? Well, that's my 7 and my 1. Coming along to this 8. What two numbers add up to be, pause. Okay, I'm unpausing it because I would like to say I made this mistake on purpose, but I did not. It was an accident. I will show you now. For this problem, remember it was 8, and I looked down and said it was 7 and 1. Well, look at this. It could also have been 6 plus 2. So what I'm going to do now is grab my eraser and say, you know what? I don't know what it's going to be yet. So what I'm going to do is continue to go around and fill in the ones that I definitely know for sure. So let's watch. Let's go back up here, grab my pen. There. Okay, so let's continue. What two numbers add up to 7? Well, let's see. Look down here. The only thing that can possibly add up to 7 is 6 and 1. Okay, so this is going to be 6 and 1 or 6. When I look along, there's already a 6 in the top row, so this is going to be the 1, and this is going to be the 6. Now, these two numbers, what adds up to be 6? Well, that's got to be, what haven't I used yet? That's my 2 and my 4. Okay, now I come along to my 8, and again, it could be 7 and 1 or 2 or 6, so I'm not going to do anything there yet. What about my 6? The only two things that add up to 6 are 2 and 4. So I'm going to put my 2 here and my 4 here. And I'm just going to continue the puzzle, come back here. What can make 5? It's got to be my 1 and my 4. And then I come over here. And the idea is I'm just going to continue working my way around the puzzle. When I go to make my 10, it can only be the 6 and the 4. That helps me to see that back here, remember I wasn't sure what went here, the 1 or the 4. Well, I used the 4 in this row now, so that's got to be the 1 and that's got to be the 4. So as you can see, I have to cut the video because it's going to get to 15 minutes, but basically the idea is you go around and fill it in. There are some students in certain grades that will never even see one of these puzzles, so please know that going in. But I would imagine there's 1 or 2 or 3 or 4 kids every year that you get that there's nothing that can challenge them, and these puzzles will absolutely challenge these students. They are for enrichment. I do think that at some point, let me jump back a few screens. I do believe that at some point every student will be filling out these 3x3s. Might take some students a little longer to get prepared than others, but the 3x3s they should be able to do, and maybe even the 4x4s. By the end of the year, we would hope that every student could complete these. But the 5x5s are definitely more difficult, and they're designed to be that way to provide a challenge. All the videos after this will be more specific. They'll be on one family at a time, but this will serve to give you an overview of the entire program. Thank you.